All right, so again, today we're looking at three things: Pythagorean theorem, Pythagorean triples, and special right triangles. The main focus of this is special right triangles. Tomorrow, we're going to look a little bit more at SOHCAHTOA, our trig ratios. So we're focusing a lot on triangles these first couple days, and things that usually appear in multiple questions. So again, you usually see all the things that we're going to talk about, and not only questions that are specific to these topics, but also in many other questions as well. They usually just keep showing up. So, the first thing I want to talk about is Pythagorean theorem. Now again, you guys can copy however many notes you want, so it's up to you. But Pythagorean theorem. When do we use Pythagorean theorem?
You use Pythagorean theorem when you're trying to find the size of the triangle.
What type of triangle? Right triangle. So, find the missing side of a right triangle. Now, there are two ways that you can recite Pythagorean theorem. Either c squared equals a squared plus b squared, or if you prefer writing it the other way, a squared plus b squared equals c squared. It's the same thing. It doesn't matter if you list c first or second. Again, this is used in any right triangle where A and B are your two legs and C is your hypotenuse. And then we can also use Pythagorean theorem for one other thing. We can also use to identify whether it is a right triangle or whether it's a different type of triangle. So you have your c squared equals a squared plus b squared if you're dealing with a right triangle. But you also can say that if c squared is greater than a squared plus b squared, it's going to be what type of triangle?
Oh, what you say?
If c squared is greater than a squared plus b squared, it's what triangle?
It would be acute.
Nope.
It would be
Obtuse. And if c squared is less than a squared plus b squared, it'll be acute. All right. Next, Pythagorean triples. Now, there are lots of triples. I don't expect you to remember every single one of them. But there's at least two that you should definitely know. Can somebody tell me one of the two that I stress the most? Go ahead. Oh, that's one of our special right triangles we're going to talk about in a minute. 3, 4, 5. All right. What's the other one that I stressed a lot?
It was like 12, 13, and 5, right?
Yeah, 5, 12, 13. Again, those are the two that appear the most often. But again, are there more? Yeah. Again, are there more that will probably be on the FSA? Yeah, there probably will be. But again, these appear probably the most often out of anything. Now remember, if you know the basic Pythagorean triples, you can also take those and multiply them by any number you want. So if we doubled all these numbers, it gives us another Pythagorean triple. So 6, 8, 10 also works. Okay? Again, the more triples you know, the more it will help you save time. All right. Now, so all that stuff is about Pythagorean theorem. The next part that we have to talk about is our special right triangles. Now, there are two special right triangles. Evan, what is the first special right triangle that you had just mentioned a second ago?
30, 60, 90.
Okay. Yeah. So we have our 30, 60, 90, and our 45, 45, 90. Those are our two special right triangles. Again, there's properties that we have for each one. So, in our 45, 45, 90, it's also referred to as a isosceles right triangle because it is a right triangle that has two congruent legs. And it's called 45, 45, 90 because that's our angle measures. Same thing with 30, 60, 90. It's called 30, 60, 90 because those are the angle measures. So 30 would be the smallest angle, 60 would be the biggest angle. Again, 30 is always across from the smallest leg, 60 would be across from the bigger leg, because remember, in a triangle, we have shortest side across from smallest angle, longest side across from biggest angle. Now, let's talk about our 45, 45, 90. Well, since both angles are the same, that means that it's isosceles, and therefore, these two legs are equal or congruent. So we're going to call them both x. Now, if they're x, what's our hypotenuse?
2 squared. Or wait, no, x squared.
X squared root 2. There we go. And then our 30, 60, 90 triangle, if, again, we base everything off the short leg and call that one x, what's the hypotenuse based off the short leg?
2x.
2x. For the hypotenuse, it's 2x. The long leg is x square root 3. Yeah. Guys in the back. Shh. Shh. Yeah, it doesn't matter. It's not math related. All right. Special right triangles. So, those are the two most important patterns that you need to know when it comes to our special right triangles. So, let's take a look at some problems from previous tests, because we have done all these things before. So again, all these questions are coming from previous tests. All right, everybody good on the notes? I'll give you another minute to get them copied, and then I'll. Now, it's up to you how much of the examples you want to copy. Again, if you want to copy down each diagram, great. If you want to copy down some of them, that's fine too. I would recommend copying something down, but if you want to listen, that's up to you. But just don't randomly talk to your neighbor and don't pay any attention. I would not recommend that. All right, here we go. So, find the missing values. Now, I'm going to give you guys a couple minutes to try them on your own. But again, these are just using the properties that I just had on the board. So properties of the 45, 45, 90 and the 30, 60, 90. So again, use those properties to find A through G. All right, so all those missing pieces. Some of them are easier than others. The top two are the easier ones. The bottom two are the ones that are a little bit harder because you got to work backwards. Oh yeah, beautiful. You should braid all your hair.
It goes. Oh my goodness. It's a helmet for our bikes, sir. You should have water safety. Most kids don't wear helmets.
Oh my goodness.
I'd be on that.
They do wear helmets here.
You say you're training.
I know how to draw a triangle and circles.
What's your question? So you gotta go backwards. Alright, so 15's in the position of what? Okay. So do it like any place. So if x squared 3 is equal to 15, what is x? Again, everything that we're doing today should be able to do it without a calculator. You know, a little more wise than sometimes.
Yeah, this is a 45 times. The 10 would be also for A, and you just multiply them by each other. So it would be 100 times 100, 100 plus 100. Because you would have to square.
What is he talking about? I know. I just need 10. Need 10 times 2.
But I can do whatever I want, right? If I want to take the long way, I can take the long way. It doesn't matter if you want to say, hey, if it gets your done,
You would get home with that correct answer, I think. As long as you're able to simplify around it.
so for how do I do that?
Or is this one for the it's X, 2X. Well, this is a bit ignored because, and wait, which one? 2, I guess, E, C, G, you flipped it around. But you're fine, 30's up here. That makes a difference because this is your short leg.
It was literally just like I could dangle.
Yep. Nope. This is chicken. That's your hypotenuse.
Yes, especially when they
This is 2X. Yep. Alright. So, yeah, well, he flipped that triangle around, but that's good. Yeah.
Mr. Stevens, I hate the people in this taxi area of them.
Say again?
I hate these people.
Oh, I'm sorry.
I hate them.
I didn't make it.
It's awful. You should like cut them out. With scissors.
You gotta go backwards.
Yeah, very.
So, one thing you can do, what is this normal? Which part of it? Yeah, it's not. Okay, so then you off around.
I need to drown them.
Go back.
So 15 equals X3.
And then stop around.
Yeah.
Here, I'll come back. So you have to divide by
Would be 15.
But you can't do radical denominator.
So what do you do?
Rationalize.
How do you do that? What is that?
Multiply by the radical on the top and bottom. I'm gonna do it. All right, let's. All right, come back to me here. Listen. So we're gonna go over these now. Again, top 2 are easier because they were pretty straightforward as far as the properties went. The bottom 2 a little more challenging because you had to go backwards a little bit more. So on the first one, hopefully everybody got A. A is 10. Yeah. So these 2 are congruent. Therefore, this one is equal to 10. So, then B, 10 radical 2. Yeah, we're just taking the leg, multiplying by square root 2, and a 45, 90 to get our hypotenuse.
It's so close.
All right. Now, on the next one. So, the hypotenuse is 8. Everything is based on the short leg. So, we got to get the short leg first. So, go backwards. This is 4. And we know that one's the short leg because it's across from the 30-degree angle. All right, so it's facing a different direction. But again, it's across from the 30, so that's our short leg. So if that one's 4, the long leg is 4 radical 3. All right, not too bad on the top 2. Now, the bottom 2. So these 2, guys, you probably want to pay attention because I'm not sure how good your skills are in this one. Hello. Jasmine, okay. All right. Thank you. All right. No. Okay. Again, I'll post everything else. All right. So Where was I? On here. All right, we got our 30, 60, 90, right? Now, we have the long leg given to us. We need to go backwards in our short leg. Now, again, if you know your patterns, we essentially have to get rid of our radical 3. This one doesn't have a radical 3. But we're still doing the same steps. We're going backwards. We're dividing off the radical 3. If that's confusing to you, what you could do is set up as an equation. So, normally this part, the long leg, would be equal to x radical 3, right? Where x represents the side that E is right now. So, if we want to get E, we solve for x. So, get rid of our radical 3. Now, oops.
Did I do it worse?
But now we get something with a radical in the denominator.
Which is bad.
That's no good. So, instead of really making this that much better, it looks a whole lot worse, right?
Yes.
But we got to now rationalize. So you rationalize the denominator to get the radical out of the denominator by multiplying by the exact same radical on both the bottom and the top.
Awful.
So now we end up with 15 times radical 3 over, no matter how you simplify this, it's going to give you 3. So you could either say square root of 3 times square root of 3. It's like you're squaring that, so the square and the radical cancel out and just give you 3. Or you could say 3 times 3 is 9, square root of 9 is 3. Either way, the bottom is 3. So now, 15 divided by 3 is 5 radical 3. So that's E, 5 radical 3. And we know what that is. We now know the hypotenuse is 10 radical 3. We're doubling the short leg. Now, there is more than one way that you can do this. So I showed this with rationalizing again, but I also gave you guys a pattern. Anytime you divide by a radical, it always happens to be the same pattern because you always have to go through the process of rationalizing that denominator. So if you divide by a radical, what you're really doing is dividing by the number that's under the radical and then multiplying by the exact same radical. So in here, if we take 15 and divide by square root of 3, we're really just dividing by 3, which gives us 5, and multiplying by the square root of 3.
Oh, snap, so you don't really need to do that. Just gotta remember to add around 3 and divide by whatever.
Again, you should know why you're doing the math. But again, that's what happens when you rationalize. It's going to be that same thing. Every single time you rationalize, the same outcome happens. You end up dividing by the number underneath the radical, and then you end up multiplying by the same radical. Can somebody answer that for me? All right. On the next one. So let's skip the rationalizing part. Let's go straight to solving on this one. So if I go backwards, I have to divide off the square root of 2. Oh, okay. I've been looking for it. Thank you. I thought I lost it. All right. On here, divide 6 by square root of 2 because we're going backwards, and this is our 45, 45, 90. So if we divide that by square root of 2, divide that. Radical 2. But yeah, so again, divide this by 2, you get 3. And then multiply by radical 2, you get 2. Right? So this is it, 3 radical 2. And it's going to be the same for both sides. Now again, if you want to show your work, that's fine, you can show your work. So 6 divided by square root of 2, again, you end up having to rationalize, which means you are multiplying by the same thing on both top and bottom.
Something tells me my algebra teacher didn't.
And again, it reduces, and you get 3 radical 2. Again, it's much easier to know that pattern, but again, you should know why you're doing it. You have to rationalize to get rid of your radical, and that's how you get rid of your radical, by multiplying by the same radical on top and bottom. All right. Any questions on that page? All right, so now that we did those 4, changing gears a little bit. New problem. Find Z. Find Z.
Find that. Got it.
Z.
Find Z.
Zeta.
Okay, I'm gonna start this.
Find Z.
Okay.
Wait, do we have to do this?
Find the values.
This is B.
I mean,
Oh, this is 3. That's I read that thing already. Is there enough information there?
Plenty of information.
Hold on.
Yeah, there isn't enough.
Pardon?
There isn't enough information, sir. Thanks for the trick question.
It's a 30, 60, 90.
Why trick?
I don't like this one.
Good realization.
I would say that one is
Tell them what you just said
definitely
again.
90.
Tell them what you just said.
Okay, so I figured out one of the ones is definitely 90. I can almost guarantee.
Okay, before you guys keep struggling, what realization do you have to come to here?
There's no angle measures.
No angle measures. So is this a 45, 45, 90?
No.
Is this a 30, 60, 90? What is it?
I just said trick
Sad.
question.
It's a right triangle. It's a right triangle. So how do you solve a right triangle? Pythagorean theorem. If you have two sides, find the other side. Again, not a trick question. Again, it's not going to come out on the FSA and say, use your special right triangle to solve this question. Use Pythagorean theorem to solve this question. You have to look at it and see, hey, what information do I have? If you have two sides of a right triangle, you can always use Pythagorean theorem. If you were given the angle measures, then you could have maybe done a special right triangle. Or if the pattern here followed that of one of our special right triangles, then you could continue the pattern as well.
It sounded like an infomercial, so why is that really a good thing that you should buy? And buy one get one free.
Today I'm going to sell you Pythagorean theorem.
You can always use Pythagorean theorem.
I finished before.
I finished after the stretch break. I took my
Pythagorean? Pythagorean.
Is it with an N or an M?
An N. Pythagorean.
Pythagorean. I like Pythagorean.
The guy's name was Pythagoras.
I say Pythagorean.
Huh?
I say Pythagorean. No, Pythagorean.
No. Yeah, the guy's name was Pythagoras. Pythagorean. Yeah, just look at that stuff.
Pressure.
Alright. Let's go ahead and go over this one. So now,
Are you blowing?
on here, we had 4 and 6 given to us. Again, this is a Pythagorean theorem question. Now, so we had 4 and 6. Which one's our C value? The 6. This has to be our C. These can be our A and B. Alright, so C squared equals A squared plus B squared. 6 squared equals 4 squared plus
B squared.
Z squared.
You want B?
I plugged it in.
Disagree.
6 squared is
36.
4 squared. Subtract off the 16. Now, how do you get rid of the square?
You do the fancy
Square root. Now, in order to simplify the radical, you could do the factor tree, or you could find a perfect square that goes into it. Remember, you can always use a factor tree if you want to, right? Sometimes, guys,
Come on.
again, sometimes a factor tree is fine, but sometimes a factor tree is going to take really long. So again, if you know your perfect squares, they help out because everybody should be able to identify a perfect square that goes into 20.
4 5.
4, well 4 is a perfect square, right? So 4 times 5 gives us 20. Square root of 4 is 2. So 2 radical 5 is our final answer. All right. It's cute.
I was being sarcastic.
No. Okay.
Come on now.
All right. I just love cute math. I don't know. You said it was cute. It just sounded weird when you said it. So I thought I'd emphasize how weird it sounded. All right, here we go. Here we go. Now, next question. This one, are they giving you a right triangle?
Oh my god, wait, period.
They're not talking about right triangles, but are you still going to use the properties that we were just going over? Yes. So again, take a minute, find the height of that equilateral triangle. Oh, did you pack it again?
Oh, give you breakfast with
You know you could have there for an hour.
Fine.
Test open.
To go away.
No, we can't. No, it's not.
Oh, that one doesn't give you
It's not the,
a minute time.
it's 90 minutes.
Oh yeah, I would have sat there like this.
90 minutes no matter what.
Unless you have a special accommodation. So I drag them.
The reading one is just 90 minutes for everybody.
Oh my goodness, I got
Everybody left the room at the same time.
Some people got like extended.
Well, for math it's different. Because for math you still got to have For this class, you guys can be there for 120 minutes. So you don't have to sit there to go. Yeah, somebody asked a question about it. Alright, here we go. On this one.
Wait, let's do that. Get out of the way. Thank you.
Oh,
Okay, continue.
continue? You sure?
Yeah. Let's just do that. Can I already get water?
On here, what do you have to do first? Okay, so we draw our equilateral triangle. And we draw on the height. An equilateral triangle, what are all the angle measures? 60. So this would be 60, this would be 60, this is right. And we split the top one, so this is 30.
Can I already get water real quick?
Yeah, go ahead.
I'll be back soon.
The answer is, yeah. Now, so if this is 12, 12, and the whole thing is 12, this is half. This is a 30, 60, 90 triangle, so based on that short leg, this is 6 radical 3. Now again, we use that a lot, especially when it came to our heptagons. When we had them as bases, we use that to find the apothe, right? We use this quite a few times. It's been in like the last 5 sections. So again, we keep seeing this one. Alright. So we got one more. We at least have time for this one. Alright, again, this was a test question that a lot of people missed when we took the test. But it's, again, it's a 30, 60, 90. A lot of people looked at it, thought they had to do trig. Didn't have to do trig on this. Again, you didn't have to use sine, cosine, tangent. It's a 30, 60, 90. You have the 30 degree angle. It says that velocity is at an altitude of 110. We need how far did the bird travel, right, to get the fish. So, how far do it have to fly? We're looking for this side here. So, what do you have to do with the 110? And that's our answer.
Never mind.
All right. How much time? Yeah. All right. We'll stop there. I got a couple more. I'll post all the questions I was going to do today, as well as their answers on SB. Again, I'll post a video on SB for people that weren't here. And I'll do the same type of thing each day. So we'll have a little review session. We'll go over some practice problems, and then, that'll be it.